Welcome to a rate on exercise 6F, rates from graphs. And yeah, we're just looking at rates and how to figure out rates by looking at a graph. So what is a rate? A rate compares two quantities. For example, you might be comparing kilometers per hour, distance over time. So when you go on a car trip from here to Canberra, natural question is how fast are you driving? So that is a rate. It's a rate because it's kilometers per hour. You're looking at kilometers and hours. You're comparing two of them. How many kilometers do you travel over 1 hour? There's two units of measurement here, kilometers. And I'll pull out my pen. So there's car speed. We say 60 kilometers per hour. Notice that you have kilometers, which is one way to measure. That's how you measure distance, right? So that's distance per hour. And that's time. Measures time. Measures distance, measures time. So kilometers measures distance, hour measures time, and your speed is a rate which is comprised of both. A rate comprises of two different units of measurement, and we're comparing them with each other. Because, for example, if I said to you, what is your car speed? And you told me 50 kilometers. Well, 50 kilometers is a distance. It's not speed, is it? Doesn't make sense. 50 kilometers in a second, 50 kilometers, in an hour, 50 kilometers in a day. So if someone said, if I asked you guys, what is the speed of light? And then someone said 30 meters, 30 meters what? 30 meters per minute, 30 meters per hour, 30 meters per second, 300 meters per millisecond. Like, what is it? It doesn't make sense on its own. You need to have two different units of measurement to give speed. Speed is a rate, and you need two different units of measurement. 300 meters per second is the speed of light. So we're comparing two units, distance over a period of time. Now, it's very common to have kilometers per hour, and you also have liters per second. So for example, if you are filling up a big water tank, and if you're filling up a big water tank, so if you have something like, that's the water tank, let's say, and you're filling up the water tank, the water is going in. So how fast is it rising? How fast are you filling up? Well, you might say, for example, 50 liters per second, or 1 liter per second. I don't know. Or 1 liter per minute, for example. But yeah, it's a rate. You're comparing how much water is going in over a period of time. So hopefully you've understood what a rate is. It just compares two different units. And we're just going to be looking at graphs and how to interpret a graph to find the rate. The rate at which something changes can be analyzed by looking at the gradient of a graph. So this is related to gradient. It shows you how fast something is changing, which is what gradient does. Remember, a gradient tells you how much something changes for 1 unit of the x-axis. Hopefully you remember that. I say here's a graph depicting a car journey. And so you're starting off at 0, and then after you, in 2 hours time, you're traveling 100 kilometers, and you can see over here it's 100 kilometers and over 2 hours. Okay. So yeah, you're going 100 kilometers in 2 hours. So how fast was the car going? To find out how fast the car was going, we can look at rise over run, because we can use the gradient to find the speed of the car. And so gradient is rise over run. What is the rise? Well, the rise was 100. It rose by 100 kilometers. Yes, it rose was 100. And how much did it go across? 2 hours. 2 hours. So 100 over 2. 100 divided by 2 is obviously 50, or 50 over 1. And that's why we say 50 kilometers per hour. We say 50 kilometers per hour. 50 kilometers per 1 hour. Now, if you ever remember, if you get some complicated word question, like, Zaria traveled to Brisbane, and Brisbane is a distance of 900 kilometers, and it took Zaria 5 hours. How fast was Zaria traveling? Well, how fast was Zaria traveling? Remember, we measured kilometers per hour. So all you would need to do is you would look at however many kilometers there were divided by the number of hours it took. That it's so the how to do the question is actually hidden in the kilometers per hour aspect of speed. I hope that made sense. So it would be 900 kilometers. Brisbane is 900 kilometers, and it took Zaria 5 hours. So you do 900 divided by 5, which I can do in my calculator. 900 divided by 5, 180. Zaria must have been going 180 kilometers per hour, which is very fast, obviously. Completely made that up. Not a realistic example. Okay, so let's have a look at a worked example. A four-wheel drive vehicle completes a journey, which is described by this graph. And so you have a graph here. And for the first hour, so we're looking at the first hour only. We're only looking at this bit. We're only looking at the first hour, right? Find the total distance traveled. Okay, the total distance traveled in 1 hour was 100 kilometers. Okay, that distance there is 100 kilometers. So 100 kilometers. Find the speed. Well, speed is going to be, and this is what I was referring to earlier, speed is going to be given in kilometers per hour. So I need to know what the kilometers are. Another way I can write this, kilometers per hour. Another way I can write this is kilometers over hours. So how many kilometers? 100 kilometers. And how much was the speed? How much was the time? Because in hours, we don't know hours. Hours is 1. So 1 hour. So 100 divided by 1 is just going to be 100. And so we can deduce speed is 100 kilometers per hour. And let's look at the next question. So the next question says, how fast was the four-wheel drive traveling during the second section? So this is the second section. Okay, how fast was it traveling? Again, it's speed. So to get speed, we need to know kilometers over hours. How many kilometers did it travel in the seventh and the second section? Well, it's 0 because it traveled 100 kilometers and then it stayed there. As you can see, it stayed there 0 kilometers. It didn't go further away. It wasn't traveling further away from the origin. This is where you start off and you travel, and you've traveled 100 kilometers away. Then you stop traveling. You must be taking a break or rest or something. That's why you're not getting further away. The distance remains at 100. So 0 kilometers per, doesn't matter how many hours. I think it's 1.5. But if you're not traveling, your speed is going to be 0 kilometers per hour. And then it says, look at the third section. So let's look at the third section. So how much do they travel, rise, or just, for the third section as well, you need to know kilometers per hour. So I'll stick to the method I was doing earlier. So to find the speed on the third section, you need to know kilometers per hour. How many kilometers was traveled between there and there? 100 to 150, so 50 kilometers. In how many hours? Well, it was 2.5, and then it reached 4.5. So that's 2 hours. Because 2.5 to 3.5 and 3.5 to 4.5. That's 2 kilometers. This is 2, not kilometers, hours, 2 hours. So 2 hours. Now you do 50 divided by 2, which is 25. 25 kilometers per 1 hour. So we're over here. All right, 25 kilometers per hour. Feel free to send me any questions you may have via Zoom chat. Moving on, because I haven't received anything. Moving on. So it says a container is being filled with water from a hose. So there's a new worked example. Container is being filled with water from a hose. And so you might have a container like this. Let's just say and you're filling it up with water. So let's say that's the water. To give the rough drawing. So we're filling it up with water from a hose. So let's say that's the hose, and you have water coming out from there, filling up the container. How many liters were filled during the first 10 seconds? So now time is in seconds, and it's asking you how many liters were filled in the first 10 seconds. Well, that's the first 10 seconds. And then no amount of water filled was 5 liters, it would seem. 5 liters. Because it's 10 there, this has to be a half. And so 5 liters. How many liters were filled during the final 10 seconds? Okay, the last 10 seconds, or are we from there to there? So it was at 10, and then it became 20. So how much is filled? 10 liters. Because you were at 10, it became 20. 20 minus 10 is just 10 liters. How fast was the container being filled during the first 10 seconds? So now we're talking about rate. So let me just tidy this up so we can look at the rate. Now, how fast, what rate in liters per second? That is telling you how to figure out the answer. We're going to do liters over seconds, and we're just going to simplify. So how many liters? In the first 10 seconds, how many liters? 5 liters, right? 5 liters. In how many seconds? 10 seconds. And so 5 divided by 10 is 0.5. 5 over 10, you can put on the calculator, you'll get half. Half, or you can think of it as 0.5, and then you just write down liters per second. Okay, 0.5 liters per second. This is a very handy tool. You need to look at how they want you to measure, how they want you to measure the rate over here. They're telling you to measure the rate in liters per second. That L over S is literally telling you how to do the question. You write L over S. On the top, you write down liters. At the bottom, you write down seconds. And you just simplify on a calculator. You simplify the fraction. 5 over 10 is 1 over 2, or half, right? Half, 0.5 is a half. And we just write down liters per second. So it tells you, it's actually in the question itself. Moving on to the next question. How fast was the container being filled during the final 10 seconds? Okay, let's see. So once again, it's still in liters per second. So in the final 10 seconds, how many liters were filled? Between here and here, how many liters? Well, it moved from 10 to 20, so 10 liters. And how many seconds? Well, 20 to 30 is also 10. And so we have 10 over 10, which is 1. And then write down liters per second. So 1 liter per second. And then it says between the 10 and 20 second mark, that would be 5 over 10. So you can see how much did it change. So I'll stop being lazy and I'll actually do it. So once again, we're looking at we're looking at third question now. How fast in liters per second was the container being filled between the 10 and 20 second mark? So between those two areas, right? So how many liters? Well, 5 to 10, so 5 liters. And how much time? 10 to 20 seconds. So that is 10 seconds. And 5 over 10 is just 0.5. So right, 0.5 liters per second. So I hope that was helpful. You can always ask me for more help. I'm going to be here on Zoom for the whole period. If you have any questions, so I would encourage you to stay. For the guys doing it afterwards and watching this on YouTube, you can reach me on Slack, ask me any time of the day, pretty much up to like 9-10 p.m. or so. Ask on Slack. Please do make use of your teachers. Get the work done. Please do not copy answers from the back, as a lot of you guys are doing. Come on, it's very obvious when there's a lot of working out involved and you do no working out whatsoever. It's very obvious that you copied answers from the back. So please do yourself a favor and get the work done, because this is your education. This is your future. You're not doing it for me. You're not doing it for your parents. You should be getting yourself educated for you, for your own sake. So please get the work done properly. It's you can watch the video again if there's any confusion or misunderstandings or whatever. But yeah, I don't think it's a particularly challenging topic. The answer or how to do it is actually given in the question itself, in the rate, liters per second, meters per second, kilometers per hour, whatever it is. Anyway, best of luck, and yeah, get the homework done properly.